So in this video, we're going to talk about factorials and permutations. So what do we mean by factorials? 0 factorial is 1, 1 factorial is 1, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, 4 factorial is the same as 24, 5 factorial is the same as 120, therefore n factorial is n times n minus 1, n minus 2, etc. till we reach 1. Some examples about factorials. So 9 factorial over 7 factorial, we can do this mentally. 9 factorial is the same as 7 factorial times 8 times 9 over 7 factorial. We can cancel the 7 factorial. And we're going to end up with 8 times 9, which is 72. 100 factorial over 99 factorial, that's the same as 99 factorial times 100 over 99 factorial equal to 100. 7 minus 3 factorial is the same as 4 factorial, which is 24. 4 times 3 times 2 times 1. And 24 over 4, that's 6. And 6 factorial is the same as 6 times 5 times 4 times 3 times 1, which is 720. Permutations, an order arrangement of objects is called a permutation. So we're going to see two definitions of permutations. That's the first one. An order arrangement of objects is called a permutation. So if I have three different circles or three distinct circles, what's the number of permutations formed with using three distinct circles? So let's see what they are. So notice we have 6, and 6 is the same as 3 factorial. If I have the word math, what's the number of permutation of the letters in the word math? And keep in mind the word math has 4 distinct letters. So let's see what are the permutations. And if I count the permutation, they are 24 or the same as 4 factorial. What if we have the word book, and notice we have O, we have 2 O's. So what are the number of permutations? So let's see what are the permutations first of the letters in the word book. So these are the permutations. And if I count them, they are 12. Now actually they are 24. But because I have one letter got repeated, notice for every word we have a duplicate. And we can't write the same word twice. So we don't need the duplicates. So therefore, the number of permutations of the letters in the word book is 12. Now we have a formula for permutation. Now we have a formula. The number of permutations of n items where p items are identical, q items are identical, r items are identical is given by the formula you see. Now n is the number of letters of the word book. PQR, P we're going to represent how many times B is repeated, Q how many times O is repeated, and R how many times K is repeated. Therefore, plug in the numbers in the formula. And notice in the bottom we have 1 factorial times 2 factorial times 1 factorial, which is 12. How many distinct permutations can be formed using the letters of the word Tennessee? So we're going to use the formula. We're going to increase the variables because we have Tennessee has 4 distinct letters. Now N is how many letters in the word Tennessee. P how many times T is repeated. Q how many times E is repeated. R how many times N is repeated. And S how many times S is repeated. And N how many letters of the word Tennessee. Plugging numbers instead of the variables. Keep in mind in the bottom we have 1 factorial times 4 factorial times 2 factorial times 2 factorial. We're dividing 9 factorial by the product in the bottom. We're going to get 3,780. Another definition for permutation is NPR, which is n factorial over n minus r factorial, and that's the arrangement of order arrangements of r objects from n objects. So in permutation, the order matters. So it's the number of arrangements of r items from n items where order matters. So let's see examples. 6p2, we're using the formula. It's the same as 6 factorial over 4 factorial, that's 30. 3p3 is the same as 6. And 4p0 is the same as 1. How many ways can we award a first, second, third place prize among 7 contestants? So the awards are gold, silver, and bronze. So we have 7 contestants and we need to award them. So for the first award, we have 7 choices. Suppose, let's say A won the gold. So for the first award, which is the gold, we have 7 choices and we gave it to A. So now for the second award, the silver, we have 6 choices. Let's say B won it. Now we're left with 5 choices and let's see C won it. So this is the same as the number of total choices, the same as 7 times 6 times 5, that's 210. Or we can use permutation. 7p3 is the same as 7 factorial over 4 factorial, and that's 210. So 210 ways we can award a first, second, third place prize among 7 contestants. In how many different ways can we seat 4 people, Sam, Dan, Anne, and Yan, in a row such that Sam and Anne are always next to each other? So we need to seat 4 people in a straight line such that Sam and Anne are always next to each other. So let's see in how many ways. That's 12. Or it's going to be 4p2 4 factorial over 4 minus 2 factorial, that's 2 factorial. 24 divided by 2, that's 12. Now we can solve the previous problem using a different method. So suppose we tie the 2 people, Sam and Anne, and treat them as one person. So trying to seat 3 people, the 3 factorial, we have 3 factorial different ways, but since 2 people are tied together, so that's 2 factorial ways, so there are 3 factorial times 2 factorial, so that's 6 times 2, 12 different arrangements. In how many different ways you can select a president, vice president, and a secretary from a group of 12 people? So that's 12p3, that's 1320. So for example, this is one way, but we have so many ways. Circular permutation, the number of permutation of n elements in a circle is n minus 1 factorials. For example, in how many different ways can we seat 6 people on a circular table? So we need to seat 6 people on a circular table. In how many ways, in how many different ways can we do that? So according to the formula, that's 6 minus 1 That's 5 factorial 120